Assalamualaikum warahmatullahi wabarakatuh.
I'm Gita Octavia.
I'm Burhanuddin Yamani.
I'm Musbida Kartika Wilis.
Now we are going to present you about Jabrig production analysis by using linear programming and integer programming. So
Here's the presentation.
Jabrig is a meatball restaurant at Telkom University area. Jabrig is located in PGA, which was established in 2006, owned by Mr. Yanto. His products are bakso cincang, bakso urat, and bakso kecil. Firstly, Jabrig did not have any place sell the menus, so Mr. Yanto sold Jabrig by using cart walking around Telkom University area. But then he decided to build a small restaurant in front of BNI Bank near Telkom University main gate. And 4 years later, Mr. Yanto decided to build his own permanent place for his business in PGA. It still exists and get more consumer not only from students of Telkom University but also people from any other place. Jabrig produce some kinds of bakso. Jabrig want to decide the production instead of those kinds to reach their maximum revenue but limited by the capacity. In this case, our group want to identify how many bakso should be produced. Kind of bakso are bakso cincang, bakso urat, and bakso kecil. To make bakso cincang, we need 65 grams of meat, 6.5 gram of kanji flour, 1 gram of salt, and 0.06 gram of MSG. For bakso urat, we need 45 grams of meat, 4.5 gram of kanji flour, 0.625 gram of salt, and 0.04 gram of MSG. And for bakso kecil, we need 5 gram of meat, 0.5 gram of kanji flour, 0.1875 gram of salt, and 0.0125 gram of MSG. The capacity of meat is 24 kg, kanji flour is 24 ounce, salt is 4 ounce, and MSG is 0.25 ounce. The price of bakso cincang is 10,000 rupiah per meatball, bakso urat is 5,000 rupiah per meatball, and bakso kecil is 1,250 rupiah per meatball. And this is the table that limited source explained before.
So this is the mathematical model. If you want to make the mathematical model, you should know the decision variable, objective function, and the constraints. The decision variable in this case is x1 is bakso cincang, x2 is bakso urat, and x3 is bakso kecil. For the objective function, because we want to know the maximum revenue of Jabrig production, we use maximum Z. Maximum Z is 10,000 x1 plus 5,000 x2 plus 1,250 x3, and for the constraints is 65 x1 plus 45 x2 plus 5 x3 less than equals to 24,000, and the second constraint is 6.5 x1 plus 4.5 x2 plus 0.5 x3 less than equals to 2,400. And for the third constraint is x1 plus 0.625 x2 plus 0.1875 x3 less than equals to 400. And for the fourth constraint, there is 0.06 x1 plus 0.04 x2 plus 0.0125 x3 less than equals to 25, and x1, x2, and x3 more than 0. So this is the initial table in QM software. If you use the QM software, you should fill the table in QM. And in QM software, there is objective function, variable, and the constraint itself. And because we want to know the maximized revenue of Jabrig, we should know each price of the product. And for the maximize Z is 10,000 x1, 5,000 x2, and 1,250 x3. And for the constraint of meat, we have 65 grams x1, 45 grams x2, and 5 grams x3 less than equals to 24,000. And for kanji flour constraints is 6.5 grams x1, 4.5 grams x2, and 0.5 grams x3 less than equals to 2,400. And for the salt constraint is 1 grams x1, 0.625 grams x2, and 0.1875 grams x3 less than equals to 400. And for the monosodium glutamate constraint is 0.06 grams x1, 0.04 grams x2, and 0.0125 grams x3 less than equals to 25. And demand of bakso cincang, bakso urat, and bakso kecil is more than 0. This is the linear programming result. So the solution of linear program result to get the optimum solution is for bakso cincang is 347.8261, and for bakso urat is 0, and for bakso kecil is 278.2609, and the maximum revenue we'll get is 3,826,086.96. This is the ranking and solution list table. Firstly, I would like to explain you about ranking table. From the table, there is a reduced cost value for each variable, which are bakso cincang, bakso urat, and bakso kecil, which is the value is 0, which means that production of this variable is already optimum. And on ranking table also there are original value, dual values like surplus, and lower bound and upper bound. Original value for each constraints, which are meat, kanji flour, salt, and monosodium glutamate, are 24,000, 2,400, 400, and 25. Meat, kanji flour, and salt can be decided already optimum or full capacity by signing slack or surplus is 0. Besides, value in dual value is optimum value of meat, kanji flour, salt, and monosodium glutamate based on dual simplex method. And lower bound and upper bound is used to do sensitivity analysis. Lower bound and upper bound objective function coefficient for variable of bakso cincang is 1,794.12 rupiah until 16,250 rupiah, and for bakso urat is infinity until 6,630.44 rupiah, and for bakso kecil is 769.23 rupiah until 1,875 rupiah. Based on that value, means coefficient can be changed as those range. This objective function cannot change its optimum value. Lower bound and upper bound objective function coefficient for constraints of meat is 20,250 until 24,000 grams. For kanji flour is 2,400 until infinity. For the salt is 369.23 until 409.15 grams, and for monosodium glutamate is 24.35 until infinity grams. Based on that value, means coefficient can be changed as those range. This change of constraints will not change any revenue value. And for the solution list, based on the table above, shown that analysis result of bakso cincang is 347.8261 meatballs, and bakso kecil is 278.2609 meatballs. To get the optimum revenue is 3,826,000 126,087 rupiah. So this is the iteration table. The function of iteration table is to know the optimum solution, and we use simplex method for iteration because the variable is more than 2, and in this case we should do 7 iterations to get optimum solution of Jabrig production.
This is the integer programming result. Based on analysis output above, known that to maximize profit, Jabrig has to produce bakso cincang 348 meatballs, bakso kecil 276 meatballs, and should not produce bakso urat. That combination will give profit as much as 3.825.000 rupiah. This is the integer programming result. Based on analysis output above, known that to maximize profit, Jabrig has to produce bakso cincang 348 meatballs, bakso kecil 276 meatballs, and should not produce bakso urat. That combination will give profit as much as 3.825.000 rupiah. Next is sensitivity analysis. Ranking Jabrig solution. Because of there are some slack or surplus that equal to 0, so we identify one of 3 kinds of constraint which are meat, kanji flour, MSG, and demand of bakso urat. We choose best constraint to do sensitivity analysis. We change the capacity of meat to get optimum solution of x1, x2, and x3 until z value is constant in integer programming. Here is the summary of sensitivity analysis table. To get maximum revenue, Jabrig should sell 348 bakso cincang and 276 bakso kecil and 0 bakso urat with total revenue 3.825.000. If Jabrig do not produce bakso urat, it will also create waste for equipment. We do sensitivity analysis by changing capacity from variable of meats, whereas if we change the capacity of meats over 24,000, it will not change the maximum revenue.
That's all about our presentation.
Thanks for watching. And we're sorry if there is any mistaken.
Wassalamualaikum warahmatullahi wabarakatuh. Bye.